This is Unit 2, Lesson 9, Comparing Linear Functions. For this lesson, we're going to be taking a bunch of different concepts and ideas that we've gone over so far this unit and this year, and we're going to be putting them all together and comparing them to one another. So let's quickly review some terms that we have talked about. The first is linear functions. Linear functions are functions in the form of f of x equals mx plus b, or they're functions that form a straight line. The next is rate of change, which is also the slope of a function and represented with the letter m. And the formula for finding rate of change is m equals y2 minus y1 divided by x2 minus x1. The third term is x-intercept, which is where the line intersects or touches the x-axis. And finally, we have y-intercept, which is where the line intersects or touches the y-axis. So as we compare linear functions today, we are going to look at word problems, graphs, equations, and tables, and we are going to be comparing the rate of change and the intercepts. First, let's review how to find the slope and y-intercept from context. When I say from context, I mean from a word problem. So to find the slope, you need to look for key phrases like each, every, per, and rate. So if I had something like $3 for each apple, $2 for every sale, 5 miles per hour. Those are all kind of low numbers, not necessarily accurate, but they represent the slope or the rate of change. To find the y-intercept, we need to look for the initial value, starting value, a flat fee, something along those lines. Now let's look at graphs. If I want to find the slope from a graph, there are two things I need to do. First, I need to pick 2 points. And then after I have those 2 points, I need to use the slope formula to calculate the slope. If I'm looking for the y-intercept, all I have to do is look at the graph and figure out where the line touches the y-axis. Let's use these concepts to look at an example. Your employer has offered 2 pay scales. The first is a base pay of $250 a week plus 15% commission. The second is on the graph. We'll look at the graph in just a minute, but first, let's look at this context problem. I need to find my slope and my y-intercept from context. So it tells me that the base pay is $250. That's kind of like the initial value. So I'm going to write that my y-intercept is 250, which means I have the point 0, 250. My slope is how much that's changing by, which it tells me here that I go up 15%. 15% needs to be written as a decimal or a fraction. So I'm going to convert that to 0.15. Now let's look at the graph, and that's going to be on the next page. Once again, I need to find the slope and the y-intercept. Well, slope is found by identifying 2 points. So I have a point right here at 0, 200, and I have another point right here at 500, 300. By using the slope formula, I can do y2, which is 300, minus y1, or 200, divided by x2, minus x1, 0. And I get 100 over 500. That fraction simplifies to 1/5. And usually you will keep your slope as a fraction, but I'm trying to compare it to a number that's already as a decimal, 0.15. So I'm going to do 1 divided by 5, and we get 0.20. The y-intercept is found just by looking at where we touch the y-axis, which I've actually already labeled that point down here below, and it's 0, 200. So I have these two y-intercepts, 0, 200 and 0, 250, and then the two slopes, 0.2 and 0.15. It's asked me to compare, so I'm going to write a little statement comparing the two of them together. I noticed that the second option has a lower starting point. It starts at 200 compared to 250. But the second option has a larger rate of change than the first option. So I said the second option pays less initially, but has a greater rate of change. Let's look at one more example that compares an equation to a table. If I'm looking at an equation, I first need to get it in the form of f of x equals mx plus b. You might think of that as solving for y. Once it's in this form, all I need to do is pick out the rate of change and the slope. So m represents the rate of change, or the slope, and then b represents the y-intercept. This is probably going to be the fastest method that you will use when you're comparing your functions to one another. If I'm looking at a table, I want to start out by finding the slope. And first I need to choose 2 points. Once I choose those 2 points, I need to use the slope formula to calculate what it equals. For the y-intercept, all I have to do is look at the table and figure out what point has an x value of 0, and then whatever the y value is what I list. So let's take these two ideas and let's compare the function f of x equals 2x plus 9 to the table that is listed on the side. First, we will start out by comparing the equation. So I need to find the slope, or the rate of change, and that is just represented by the variable m. In place of m, we have the 2. So my rate of change is 2. My y-intercept is represented by b. So for my y-intercept, I have the point 9, or the y value 9, which gives me the point 0, 9. Now let's look at the table. I need to choose any 2 points, so I'm just going to choose the first point and the second point. If I put those in slope formula, I have y2 minus y1 divided by x2 minus x1. That minus a negative becomes plus 10 and plus 2. So it gives me the slope of 2 over 1, which equals 2. So my slope in the table is 2. My y-intercept can be found by looking for the point that has an x value of 0, which is right here. So the y-intercept is at 0, negative 6. Now let's just compare these two functions to one another. The first has a slope of 2. The second also has a slope of 2. The first has the y-intercept of 9, and the second has a y-intercept of negative 6. So I said the functions have the same slope, but one has a greater starting point, or y-intercept. So you're not always going to be comparing an equation with a table. You might compare an equation with a graph or an equation with a word problem that's in context. Maybe you'll compare a context problem with a table or a table with a graph. It doesn't matter what you're comparing. You always want to find the slope or the rate of change and the y-intercept. And then once you find each of those for both functions, you can make your comparison.